Hey guys, it's Wolf from Tesla Owners US, and today we want to show you what happened to the first electric vehicle that Elon Musk drove, give him the inspiration to come up with the Tesla Roadster. The car was called T0, and we show you all the history about it and how the car ended up.
I pressed insane. I went insane.
Here we are. So now what we want to know is what happened to this Roadster. Pete Senior is explaining what happened to that Roadster. Okay.
This Roadster ended up not being charged for some time, so it ended up with a brick battery pack. Tesla's only solution to that, even up till now, is to replace the battery pack for now $29,000. What we do is we have a proprietary process where we're actually able to recover the battery pack, which is what we did, and then we found that the range was not suitable, so we ended up pulling the battery pack out completely, and we ended up repairing and replacing some of the sheets in this battery pack.
Yeah. So actually you're pulling batteries out and you're replacing them with other batteries?
Sheets, yes.
Sheets, yeah.
What does sheets mean?
So there are 11 sheets in that, right? Where there's compartments, right? Okay,
there are 6,831 lithium-ion cells in one of these packs.
1860?
18650.
18650, correct. They are mounted in bricks, and there are a number of bricks in each sheet, and there are 11 sheets.
I understand.
Yeah.
Yes. And so what we do is, if you come around to the front here, you can see the sheets themselves. Each one is around 35 volts, and then connected in series, they end up with around 400 volts DC.
Sehr interessant. Hier könnt ihr mal die... Oh, sorry.
That's okay.
Oh, it's not.
So there's 35 volts on each one of these sheets, and you can see they're all connected in series. If I put my fingers across two, I get 35 volts. Now I have 70 volts, and if you continue going down, you eventually start feeling the voltage.
Okay.
You certainly don't want
Not for me.
400 volts, yeah. Part of the process is the sheets have to be balanced before they will correctly calibrate themselves. So what we do is we use resistors, 100 ohm resistors, and we put those across the sheets to make sure that the voltages are as similar as possible. And we'll take a reading on some of these sheets. They should be around 35 volts each. So here we go. That's 34797. 34804, and what we attempted to do here was get them all as similar as possible by doing a combination of charging with this charger, which will charge up to 400 volts, and the bleeding off the current with the resistors.
Very interesting. So I had the same in Hamburg. There was a Roadster.
The T0 was a car that was commissioned by actually the federal government in 1997. A company by the name of AC Propulsion Systems in San Dimas, California, got a government grant to build a electric sports car. And they had a budget for 3 of them. They built the car. They used Optima spiral wound cells, which is a lead acid battery. They didn't use lithium ion.
Yeah.
And the range was only about 80 miles. But the performance was equal to the European exotics, Lamborghinis, Ferraris, McLarens. And they began to prove that this car was quite viable. There's some Laguna Seca track runs that you can Google and see. And anyway, it was the first real electric fun sports car. So Martin Eberhard came along at some point and decided to build a car company called Tesla Motors. It wasn't Elon Musk that started Tesla, it was Martin Eberhard and Mark Tarpenning. And they, instead of using or continuing with the lead acid cell batteries in this T0, which AC gave to them to use as a test mule, they converted the battery system to what was back then called laptop batteries.
Yeah.
And it was, of course, lithium-ion cells, and now they got a range of 400 miles, and they improved the performance from 0 to 60 in 4.2 seconds to 0 to 60 in 3.4 seconds.
Wow.
And now suddenly there was an even more interesting car. Hello, what you see here is a AC Propulsion Systems T0, which is the first electric sports car. It was built in 1997. There are 3 of these in existence. This car was the test mule and the genesis and seed of the Tesla Roadsters that Tesla built and started delivery in 2008. The electronics in this car were the template for all of the Roadster design. Same basic premise: batteries, DC storage system, AC inverter, and AC induction motor. The batteries in this car are actually on the sides or in the doors. This section right here, all the way back to here, here is full of batteries, as is the other side. The cells in here are Optima lead acid type batteries, and we'll open the top here. You can see the inside of this. It's 1997 technologies. LEDs were still dim. The rest of the bulbs on this car are incandescent, old school headlights, turn signals. And we can open up the back and we'll take a look at the electronics in this car. The batteries are actually air-cooled. They have thermocouples on each battery checking the temperature. And this box right here is the DC to AC inverter that converts all that DC power to AC to drive a propulsion motor that sits underneath driving the wheels. This car is definitely built as a prototype. You can see that in the construction. It's all fiberglass. And the original performance on this car was 0 to 60 in 4.2 seconds, which is slower than the Tesla Roadster, which gets 0 to 60 in 3.7 to 3.8 seconds. However, once they converted one of these 3 cars to lithium-ion battery packs, the performance increased to 0 to 60 to 3.4 seconds, which is actually faster than the Tesla Roadster. It was lighter and faster. This car is currently a test mule at Gruber Power Services, and we fully plan on putting this into trade shows, car shows, and EV type events. So somewhere along the way, Elon Musk came along, found out about the car, and said, you guys should mass produce this. And AC Propulsion was not a car manufacturer, and they said, well, that's not our game. So they said, but if you're interested in doing that, there are a couple guys already doing it, which is Martin Eberhard and Mark.
And JB was also in there, I think.
JB Strobel?
Yeah, wasn't he?
I don't know if he was in the early company.
Yeah.
But so anyway, Elon goes to see those 2 guys and joins, and they collaborate, and so Elon starts funding, at that time, Tesla Motors, and quickly realized that producing a Tesla Roadster was not going to be sustainable. It was not profitable. The cost exceeded the sale price of the car, and they realized that they needed to go to a different type of car. The T0 story, getting back to that for a moment. There were only 3 in existence. We found out about it actually at a shareholder meeting that where Elon Musk was standing up there, and he said at one point with a large screen behind him, we really need to give credit to a company called AC Propulsion Systems, who were instrumental in helping us start the Tesla Roadster, and then he put a picture of that T0 up there, which was bright yellow. I personally fell in love with it, and I said, I gotta have that car. That's the first electric sports car, and being a car collector all my life, I knew that this car would be exceptionally valuable someday when everything out there was electric, because it was really the first electric car that started the whole movement.
Yeah.
So we bought it, we brought it down here. It turns out we had the only functioning T0. I drove it a number of times. I had it at a car show with Rolf actually one time.
And actually, I will show the movie in this movie because I still have a couple of minutes of movie of that car.
Okay, also
Ja.
ihr könnt das Auto dann sehen, wenn ihr bei Rolf auf den Kanal geht. Da zeigt ihr mal den T0, weil er kennt den Wagen nämlich. Ich habe das jetzt leider nicht, das Filmmaterial, aber Rolf hat das.
So from there, we had it in the shop, we were maintaining it, and unfortunately a fire occurred May 5th, and we had a number of cars go up in that fire.
All right, now joining me live right now on the stream, Mark Martinez with this. Look at this developments here that we're dealing with.
Yeah, Mike, we've been keeping an eye on this from Skyfox, and this thing, it doesn't show much sign of being put out, at least not in the middle part of this strip mall here. And I did some research on this building. It comes back to a company, Gruber Power Services. There's a lot of other businesses in that area, but they specialize in batteries, the lithium batteries and other types of batteries as well.
We have the carcass now, the shell of it, if you guys would like to take a video of that.
Yeah.
To show you what's left of it
We did
Oh
already.
no, from the car?
from the T0.
Oh
Yes, let's do. Let's see it.
Jemals gebaut, hm?
So that's T0 or the remaining of that.
Mit Anhängerkupplung, guckt euch das mal an.
What was on this frame is a Piontech fiberglass body. Piontech is still in business, by the way. They still make their fiberglass bodies, at least the last time I talked to them. And from there it goes into tubular steel, which you can see here, and there were a number of aluminum components on here that melted. This disc is intact, but this one, as you can see, melted.
Yeah.
The wheels basically melted on this as well. The reason for the severe fire damage to our cars is when the Phoenix Fire Department showed up to fight this lithium-ion fire, they tried water, they tried CO2, they tried foam, and nothing would extinguish the fire on this battery. So finally they said, we can't get a hold of Tesla, no one will tell us how to fight a lithium-ion fire, so we're just going to let the building burn. So we stood there for 3.5 hours watching the flames just consume the building. This car was sitting next to a 2008 Dodge ACR Viper that had a full tank of gas. So once that melted, and the flames just engulfed this car, which is one of the reasons this one got so severely damaged. The rest of this, you can see there's a little bit left intact here. The AC propulsion motor sits here. The transaxle partially melted.
Oh yeah.
And the batteries, there were 28 Optima spiral wound batteries total in the car. 24 of them were in the doors. And there was a little door, like a Lamborghini flip-up door, that popped up here, and then you climbed down into the car, but this whole thing did not open up, because that's where the batteries were. You can see the cradles here.
Like a
where they sat.
BMW Z1.
Yeah.
It just goes a little bit down.
To change the batteries on this was quite a challenge, because although you could take the side off the car to get to these, there were 4 batteries, 4 more that sat underneath here. And the previous owner of this car, who had done his own battery change once on this car, said it was a nightmare to not only find these batteries underneath here, but then to get in there and change them.
So,
Es waren überall Batterien.
but you think that you can get it restored? You should be able to get it restored if you have the frame for that. You can buy from AC Propulsion probably with the gearbox and the motor for that, right? And the control unit, or?
AC Propulsion these days is a very small company, and we don't know how much they have left.
Yeah.
But the main thing that is missing on this car, which I don't think will be reproduced, is the power electronics module, which sat up here, the PEM in other words.
PEM, yeah.
Unlike the current Tesla Roadster PEM, which is more state-of-the-art technology, this PEM used old TTL logic chips. There were some in the PEM and some up here in the dash. And I'm just not sure that anyone in the future is going to take the time to reproduce that old technology. More than likely, if someone tackles this, they will go with new technology. A unique car in a number of ways.
Yeah.
One of the ways this is a unique car is, if you notice, there's a trailer hitch here.
Yes.
And the reason for the trailer hitch was there was a Yamaha generator back here, the same color as the car, that had a DC generator mounted on a Yamaha motorcycle engine. And this was, of course, before the age of charging stations everywhere, so if you wanted to go long distance with this car, you had to generate your own DC voltage to propel the engine in this car.
Ich weiß nicht, ob ihr mitbekommen habt, da
We had one that was 2 years bricked, and that's actually the one that started the fire. And it was that last 10 or 20% that stressed the pack enough to where we had a problem with it.
Oh, that's what there was a fire in your warehouse, right?
Yeah.
Yes.
Okay, we got the shot back there, and yeah, you can see we still have the flames here. A lot of flames in that building there, and it's
Yeah.
a total loss.
We're gonna. I wanted to let everyone know too. We're gonna have at the top of our 6 o'clock newscast coming up. We're going to have. We're hoping to get a phone interview with someone from the Phoenix Fire Department to get more information on exactly what's going on here. It's too early to tell probably how it started,
Sure.
unless someone
Started.
Here, this area.
Yeah, we were charging that 900-pound battery pack over where that table is. And
Yeah.
it was one that we had successfully brought back to about 80-90% of charge. And anyway, by Friday, the night before the fire, the pack started ticking. It was making a very slight ticking noise. We didn't know what it was, so we said, well, let's take it out here, take it off charger, and we set it here.
Yeah.
That was about 4:30 in the afternoon. I left at 5 to 5. I was at my chiropractor's, and I get a call from my wife, or they get a call saying, the building's on fire. So I jumped into the car and started driving up here, and what ended up happening is the pack was sitting here. The ticking noise became louder, and before we were able to do anything with it, flames started shooting out the front. And about 8 inches or so, every once in a while a flame would shoot out. So they went to get a forklift to pull it out further. What we should have done was taken that pack at 4:30 when it started to tick and put it outside.
Yeah.
Someone actually suggested that. The problem was it was May 5th, 2017, and it was 115 degrees outside, and this was a flat black battery pack. That sun would have just made it bake and make it even hotter. So we said, well, it's close enough to the door, let's leave it here and keep an eye on it. And that was a mistake. Before they were able to get any extinguishers and forklift to move it out, the flames started shooting up toward the ceiling, and there was about 8 feet of flames now going toward a wooden ceiling up here. And by the time the fire department arrived about 5 minutes later, the ceiling had already caught fire, and you couldn't get near the pack because it was just engulfed in flames. So that's the power of lithium ion.
Yes.
I pressed and say